Okay.
So good morning and welcome back, everybody, to the latest Collision Hub webinar series. This morning we've got Kelly Logan again from Carliner. And today Kelly's going to be talking about using the correct adhesives for the proper repairs of today's vehicle, a bit of a follow-up to our presentation the other day on rivets. So kind of go hand in hand in conjunction with one another. So really looking forward to this one as well as the rivet one the other day. If you didn't get a chance to check out the rivet one, that is available on the YouTube page now. So definitely check that out because, again, these work in conjunction with one another. So with no further ado, I am going to hand it over to Kelly. Thanks, Kelly.
Cool. All right. Thank you. Can you see my Carliner on the screen there, Jason?
Yep. You sure can. You are all set.
Okay, cool. I just want to make sure before I start talking. Let's see here. No, thank you, Jason. Like you said here, this presentation that I'm doing today kind of ties hand in hand with what I talked about riveting rivets and fasteners earlier in the week on Tuesday. The title of the presentation today is just using the correct adhesives for the proper repairs of today's vehicles. And I'm really not going to get into the chemistry and all the background on the different adhesives, but I am going to talk about my experiences working with engineers, to figure out what adhesives will work the best for the repairs that we were doing at Tesla. And then also I was doing work with the adhesive engineers at Faraday Future when I was there as well. So I'm not going to go into a long spiel about my background like I did before, but I've been in the collision industry my entire career. Started working in a shop when I was 14. Kind of today's conversation about adhesives and what goes into testing and how OEMs choose the different adhesives in the that are used on repairs. That's when I was at Tesla, I ended up project managing the adhesives development testing to identify which adhesives would work best for repairs. With definitely some interesting experiences. I had some very interesting conversations along the way. So we'll get into this. There's lots of different adhesives today used on vehicle repairs. I think everyone's adhesives have really become kind of a main part of repairs. When you looked at 20 years ago, panel bond adhesives were kind of coming around and people started using them for door skins and different things. But even back then, people were skeptical of them. Looking at the different adhesives, you go, really, you're gonna use glue. I hate using the term glue because people look at glue and look at the different types of adhesives out there. And when you say glue, I always think of Elmer's glue, right? It's stuff you used as a kid and not really that strong in the big picture. But there's many different adhesives on the market today. Ones that shops use every day, lots of different brands. Some of the OEMs private label their own. So I just threw a couple different ones out here. Fuser, Lord Fusers was a big help with this presentation when I was putting it together. I worked with Doug Craig. In my past, I've worked very closely with 3M and Fuser and some other companies as well when we were doing testing. So again, not all the different adhesives that are on the market today are created equal. It just depends on what the OEM calls for, and that's going to be one of the talking points we're going to discuss today. Is how do these OEMs come up with the adhesives that they use in the repairs? Again, just like everyone in the industry is kind of pushing towards these days, is just always follow the OEM repair procedures and the recommendations. These car companies and different companies out there that develop these repairs, they do a lot of testing and they do a lot of research to come up with the proper adhesives. You're gonna just continue to see more and more adhesives used in the construction of vehicles today. And I kind of wanted to, like I did on the earlier presentation on Tuesday, I like to give my personal experiences. I was a heavy collision technician at BMW for about 9 years. and, you know, worked on many heavy hit BMW vehicles. And I remember the E60 when it came out in 2003, and we were getting trained on this vehicle. This car was radically ahead of its time. If you're not familiar with the E60, it's the 5 Series and 6 Series that were built from 2003 to 2010 for BMW. What was so radical about the vehicle was the firewall forward was all aluminum, and the rest of the car was steel. So the picture on the right of the body in white there that you see, everything in blue was aluminum, and then everything in that orangish yellow color was steel. So this was, you know, really for myself personally, when getting trained on how to replace the frame rails and the shock towers, you know, and you know, this was really the first time that, you know, started talking about crash durable adhesives, and using structural blind rivets to replace these parts. The front end of this BMW was held together with SPRs and structural adhesive. That was, again, this adhesive was cured as it went through the paint shop in the manufacturing plant. So, you know, that adhesive was cured at, you know, over 400 degrees. And it's a 1K adhesive, so a very super strong adhesive. But I just remember myself as a technician, I was the only tech for over 2 years that repaired these vehicles, because everyone was scared or just freaked out by the idea of you're gluing and riveting a frame rail into a car, especially on the M5s in these years. You're looking at 500 horsepower in these vehicles, and yet you're expecting us to use adhesive to put these rails in. So again, this one of the things that when we went through training on the E60 is this was the first car that BMW started using adhesive in structural adhesive in many of the joints of the car. And when they talked about it, it didn't really make too much sense. I mean, we knew the front end of the car was made out of aluminum. We knew that, you know, to remove the SPRs and, you know, it was just a different process than what a technician was used to when you're repairing steel cars. But they talked about, you know, putting structural adhesive in the steel joints as well. And it never really meant anything to me until I repaired this car. This particular vehicle was actually one of the last cars I fixed at BMW. This car was just over the top of a hill at a complete standstill, trying to turn left, and it was waiting for vehicles to pass. And another vehicle came up behind it, going 60, 70 mile an hour, and rear-ended this car extremely hard. And obviously you can see the pictures. I'll apologize for the quality of the photos here. This was taken with an old digital camera way back when. Definitely didn't have the quality of what our cell phones have today. But you know, this particular car got hit very, very hard. It buckled things all the way up underneath the rear floor. And you know, when you look at this car, you go, why did they fix this thing? It's you know, obviously a very, very hard hit. Well, you know, the reason this car got fixed is it only had 40 miles on it. The BMW employee picked this car up and pretty much drove it home, and either got it in an accident on the way home or got in an accident the second day he was driving his car. So brand new car, very low miles. This was a turbo, a 535i, and it had, you know, it was an expensive car. It was close to a $60,000 car at the time. So they made the decision to fix it. I just remember cutting this car apart, and man, it was not fun. This was my first experience dealing with structural adhesives, and you can see in the bottom center picture here, you can kind of see the orange adhesive where all the spot welds are drilled out, and that was the structural adhesive that BMW used on that car. And again, just really was the first time I got exposed to it. And you know, what was interesting on this particular vehicle is in the repair procedures, because the adhesive was so strong, BMW actually recommended you doubled every plug weld wherever there was structural adhesive located. So you can see on the bottom center picture, you can see where there's already quite a few spot welds drilled out. And I ended up, you had to double all the welds. So just a ton of welding on this vehicle to be able to replace it back to OEM, the quality that the OEM repair required. So again, the E60, everyone talks about the aluminum front end, but for me, it was definitely one of the first times I experienced structural adhesive on a steel vehicle. So getting into the different types of adhesives. Again, this is something that, I'm not going to get super in depth here. I'm really just going to talk about what the testing and how they get in, how they decide to choose the different adhesives. So, there's acrylic, there's urethane, there's epoxy, and there's silane terminated polymer, STP. And those are typically more like seam sealers that body shops are used to using. And just understand that, one chemistry cannot do everything for all different types of repairs. So when you look at, acrylics, urethanes, epoxies, and the STPs, they're definitely, there's advantages and disadvantages. The structural, the crash durable, impact resistant 2K adhesives that are used for the very big structural repairs today, those will always fall under the epoxies category. Epoxies are great. They can bond bare metal. They don't have a terrible odor, and you can speed them up with heat. I know, and what some of the disadvantages are, they can be very rigid and they have longer cure times. I know when the E60s came out, it was the first time that we actually rolled a car into a paint booth to bake it. And, that was a big adjustment, trying to roll the car around the shop and get it into the paint booth and bake it. So, definitely, by baking the epoxy adhesive, you just accelerate the cure time, and actually it actually creates a little bit stronger of a joint when you bake the epoxy adhesives. So when you look at acrylics, acrylic adhesives are your basic panel bond. So a lot of different acrylics on the market. They're great for bonding bare metal. They have really good anti-corrosion properties. They have relatively fast cure times. Some of the disadvantages, they do have a unique odor to them, and they can be tacky at times even after curing. Urethanes are very common in the collision industry. We look at windshield urethanes, by far the most common. For the most part, urethanes are 1K. Windshield urethanes they dry, moisture cure, but there are definitely 2K urethanes on the market, just not as common for what we see every day. And then finally, the STP adhesives. Again, these are typically seam sealers to fall under this category, but they bond or seal. The bare metal's great. They have very low to no solvents and low isocyanates, and they low VOCs as well. So when we break this stuff down, when we talk about different adhesives, you talk about 1K adhesives, 2K adhesives. That term gets thrown around a lot. And really, it's pretty simple. A 1K adhesive is just one component. Automotive OEMs currently, and it's happening more and more on every vehicle that's built, they're using this structural adhesive throughout the joints on vehicles, and they're using a 1K heat cure adhesive. And again, these are put in to the joints when the car is being built. And then it doesn't actually cure until it goes through the paint shop and goes through the ovens to cure the paint. So a very high temperature, around 400 degrees. It can range from 350 to 450. I mean, very, very high temperature. And when you look at the different adhesives, that's one of the biggest reasons why body shops, collision shops use a 2K adhesive. For repairs, is one, they can't bake at extremely high temperatures, and like 400 degrees. And the other thing is cycle time, right? We need to get these things, the job completed and back together as quickly as possible. And for 1K adhesives, the most common that collision shops use every day are the windshield urethanes that are moisture cured. So, when I wanted to talk about the adhesives that I worked with at Tesla, we looked at, the adhesive that was used in the factory was Betamate 4601. This is a Dow product. It's an extremely crash durable adhesive, heat cured, works great with aluminum. Has great, it's got high modulus and low temperature peel strength. And I'll get into more about what those different categories mean. But it's got superior stress durability and it resists degradation over time with environmental aging. So what that means is, one of the things that when engineers look at different adhesives and are determining what they will use, stress durability is a huge factor. And degradation, and you don't want to lose strength in the joints over time. Obviously, if the car rusts out, again, going back to when I think about potholes and rust, I think about the Detroit area in Michigan. Just lots of salt on the road. You go look at you see cars driving down the road that looks like Swiss cheese. Those are the potholes that these vehicles hit every day. Just think about the vehicles that you drive and how many potholes you've hit in the lifetime of the vehicle. That's where the stress durability comes in with these tests, is because they can't have cars falling apart 10 years down the road or even 20 years down the road. I mean, obviously if it rusts out, that's a whole other scenario that you can't help that, but just over time, that's why all this testing goes into the different adhesives to make sure that the vehicle stays rigid over time. And the other thing too is with this 4601 is high sag resistance. This picture on the right shows a robot outfitted with adhesive applicator, and sag resistance is very important in a factory as the robots are putting glue or putting adhesive, on all these different joints. You don't want this stuff dripping everywhere. Again, I'm sure technicians, you guys out there have used different adhesives that some sag more than others, and especially when it's warm out, it's not fun trying to keep up with if the adhesive's running everywhere. So talking about some of the the key product features of 4601, and again, I'm going to get into what these different terms mean, but I just wanted to start with what this means. Peel strength, 16 newton meters. Again, you're going to see similar designations of measurements that when I talked about rivets on Tuesday. You're going to see newton meters. Megapascal will be something new. But you got peel strength, tensile strength, elongation, Young's modulus, lap shear strength, and impact peel. When you're looking at adhesive engineers are doing different tests on adhesives and doing research, they'll look at a number of different tests, but some of the most popular tests are a peel strength test, a lap shear test, and an impact peel or impact wedge test. These are some of the most important tests when you talk about structural adhesives being used on frame rails and different structural components of the body. In an accident, a vehicle, when it gets hit extremely hard and the frame rails start crushing or things start collapsing, you're going to see the different joints put into a peel type of mode, a shear mode, and then an impact peel where the impact of the accident is just trying to rip everything apart. So these are some of the tests that are being looked at when they're testing adhesives, and the adhesives are all done on 1-inch coupons, typically 1 inch by 3 inches. It varies by the OEM how the adhesive engineer has their spec designed, but typically 1-inch coupons, and they do multiple tests over time. When you talk about peel strength, when you talk about peel strength, that is really just trying to take it and peel it apart, similar to like when you do a spot weld test in a shop, you're just trying to peel that nugget apart. Same principle here. You're just trying to peel the joints apart and see how hard it is to do that. Tensile strength, tensile strength refers to the ability of an adhesive to stick to a surface and bond two surfaces together. Basically, how well it can stick together two pieces of metal for us in the collision world. And, when you look at elongation, elongation is the definition here is the point of failure of a given material or the distance an adhesive will stretch before it breaks. So when you look at elongation, if you have really low elongation, the adhesive is very rigid, and the rigid, the ability of the adhesive when it's really rigid will cause the joint to fracture faster. So again, these are just things that different the adhesive engineers look at and study. Modulus is again, I'll say the actual definition, which is a little confusing, but the modulus of elasticity is defined as a constant that has adhesive material that involves both the tension as the elongation. So what that means is if the value is very high on the modulus, the elongation will be more than likely very low or lower. And if the elongation is very high, if it will stretch and move a lot, typically your modulus will be the numbers will be very low. Again, this doesn't really matter anything to you guys out there that are fixing cars. This is just to kind of give you guys background on what goes into testing adhesives and how different repair procedures are developed by OEMs. Lap shear strength, a lap shear test is just basically putting two coupons, again, they're the 1-inch coupons, they're gluing them together and they're just pulling them apart across like a horizontal plane across each other. And this is a very important test. Lap shear is one of the again, one of the modes that you're going to see when a car gets into an accident. It's putting those joints into a shear type of scenario where it's trying to pull the metal joints apart across each other. And then impact peel. Impact peel is, again, this is where the 2K adhesives that are used in the collision industry today, impact peel is a very important aspect of a structural adhesive, impact resistant adhesive. Basically, with the impact peel test, it's basically just driving a wedge like an axe down through the joint to see how hard it is to break that joint apart. So again, I've got more pictures here further on in the presentation to kind of help give you guys a visual. But kind of wanted to break down each one of these, why, when you look at these different characteristics of adhesives, again, the tensile strength is a key one here when we get into looking at the other adhesives that are used, the 2K adhesives we use in the shop. And again, what does it all mean? Megapascal is a unit of pressure. Newton millimeter is a derived unit of torque. And then you'll also see some adhesives out there listed as joule, and that's a unit of work or energy. And it's just a way to measure, like Newton millimeter, a unit of torque, how much torque it takes to break that joint apart. When you look at it, you kind of think about, I think about a torque wrench. How much torque does it take to get to that point when like tighten down lug nuts, and where it takes, how far you have to go before you reach that level of torque. Again, that's where these tests come in. They measure these different tests with these units of pressure, a unit of torque, or a unit of energy. Again, when you look at adhesives, 2K adhesives, typically when you open the box or the package, there'll be a technical data sheet in the package of adhesive. And if you look at that, typically almost all the adhesive companies actually will have this information in there. It may be, it does vary, You may have it for steel coupons or aluminum substrates. So it does vary, and adhesives will vary depending on the substrate, depending on the steel or aluminum coupons that you're going to use or the testing that they do. That you will see sometimes a variance. Sometimes it's the same, sometimes it's not. Okay, so what are 2K? What are 2K adhesives? 2K are just two component. The 2K glues here. Again, I don't like the term, but has the adhesive in one tube and the catalyst in the other. So when you mix these, when you apply these different adhesives, it mixes together in the mixing tip, and then it creates a new product, basically from an A and B part. Again, the 2K adhesives that OEMs use for collision repairs are best suited for our industry, right? We're not going to be baking vehicles at 400 degrees because we'd be melting and damaging all sorts of different electronic components and interior components, and there'd be all sorts of headaches out there for everyone. So, the 2K adhesives, you mix two parts together, you have a limited work time, and then it cures. And again, obviously you can accelerate the cure time too with heat, which always helps speed up the process. And again, these crash durable, impact resistant epoxy adhesives were specifically designed to replace the 1K heat cure adhesives that the OEMs use when they build the cars. So when we talk about, panel bond versus crash durable adhesives, impact resistant adhesives, again, it depends on the brand. Again, being out there in the industry and working with technicians, I've heard it in the past, so it doesn't matter what adhesive I use. I can use panel bond, or does it really matter? Does it really matter if I use a panel bond adhesive where the OEM is calling for a crash durable, impact resistant adhesive? And absolutely, there's a big difference. So, what's the differences? Well, both have very strong adhesive bond strength, so that's a good thing. Both are very strong. The bond is very strong. Both have excellent corrosion protection, which is obviously very, very important for the life of the repair. But the biggest difference is these crash durable adhesives, these impact resistant adhesives, are also very tough. And okay, what's tough? That's kind of vague, right? When you think about tough, but tough in a sense, it's tougher in a sudden crash mode that allows the adhesive to manage and absorb the crash energy. So again, going back to the adhesive characteristics, like in a panel bond adhesive, the acrylic adhesive typically is a more rigid adhesive. So when that gets that sudden impact, like that BMW that I repaired, when that car was sitting at a standstill waiting to take a left, and that other car traveling at 60 miles an hour plus hit that car, there was an immense amount of crash energy. And, that's where this structural adhesive comes in, where you want it to be, you don't want it to be completely rigid, because it just causes the joints to fail faster. And again, tougher impact wedge peel. And I've got some more examples here further on in the presentation. So giving you kind of a visual, because again, I'm a very visual person, and I think technicians are in general, right? You can sit there, and I can sit here and talk about this stuff all day, but I like to give, I found this picture online, and I thought it gave a really good explanation of these different tests that are done on these adhesives. So when you look at a technical data sheet and you see a lap shear test, or you see a tensile strength test, or a wedge or TPL test, again, when you look at the upper left there, the shear is just a test where it's just pulling itself across the joint, measuring the shear force it takes to break that bond when you're pulling it apart. I want to say horizontally there, but the test's usually done up and down. But again, you can see which way the direction is being tested. In tensile is just like taking, it's like a tug of war, right? You're just going to pull it apart and see how well it sticks to itself. And that's the tensile strength of an adhesive. A wedge test, it's also considered a cleavage test as well. Again, it's going to run like a wedge, or even like an axe, if you will. It just drives it down through the joint to see how much pressure it takes to break the joint, to make the joint fail. And the last one there in the bottom right is a peel test. And again, this is, when we look at, like to use the resistant spot welding as an example. When you're doing a destructive weld test on a resistant spot weld, you're going to take the vice grips and basically peel it. You're trying to peel it apart. On the weld scenario, actually, you're trying to pull the nugget out and make sure that it's done properly. That's exactly what this test is doing. It's just peeling it apart. It's measuring how much pressure it takes to peel the joint apart. Jason, do we have any questions? I realize going over lots of different things here, but is there any questions that have come in so far?
Nothing, Kelly.
Okay. All right. No problem. I'll proceed. So trying to get into, again, giving you guys more visual of a lap shear test. The shear joints, just the explanation of a lap shear. So shear joints impose uniform stresses across the bond area, which results in the highest possible joint strength. So again, when an adhesive engineer is looking at, different adhesives, lap shear strength is very important, especially on a structural adhesive. And again, these are results are typically reported in Newton millimeters, but it can also be seen in joules. Adhesive companies are kind of like rivet tool companies. They like to use lots of different designations. Again, a lot of this stuff means all the same, but it just, some use different designations, and it does create confusion. But the great thing about the internet is there's lots of calculators out there that can help you kind of convert these different designations to get an easier understanding. Both pictures on the left and the right, again, when these tests are done at the OEMs, or when adhesives tests are done, it's a very controlled process. So, they're gluing these coupons together, and it's not like they just do one test. On all these tests, lap shear, T-peel, and impact wedge, they do, 20, 30, hundreds of these tests, because they're going to they want to see consistency. So, if you tested 20 of these coupon joints and you got 20 very different results, that would be a big concern. So, over time, they do a number of these tests, because, maybe the coupon that was tested had a weak point that you couldn't visually see, and the coupon prematurely failed. So, there's always an expectancy for, to do numerous tests to kind of see a consistency in the test. But these tests are very controlled. You can see, in these particular instances, they put, the one on the left, 12.7 millimeters. That's where the adhesive is applied. They have very specific bond gap. All these different things, they're very specific because they're trying to recreate the same joint in all of the different tests to get that consistency. So the peel test, it's on the adhesive side, it's generally considered called T-peel. And the reason it's called T-peel, it's the way the coupons are bent, and when they're when they're bonded together, you can see they kind of make the shape of a T. And again, this is measured just with a very calibrated machine on the right there. That's a testing equipment that's commonly used for T-peel, and it's also for lap shear as well. But that's a very expensive piece of test equipment that's calibrated. And they test all these coupons again in the same way, and that's why if you look on the left side picture there, they have it measured out 25.4. So on all those coupons on that particular test, they would clamp it down an inch inward on each side of the coupon to, again, on every single test that they did to create that consistency. But again, this is just peeling it apart. Again, just checking it. And when you look at lap shear and T-peel and impact wedge, again, these are the things that happens in a collision accident in a car when you have a very severe accident and frame rails and everything starts collapsing. This is where these test modes are very important on the test side. Impact wedge peel. So the picture on the right is actually again a testing device for the impact wedge. It may be kind of hard to see, but the wedge there is you can see the metal coupons that are kind of spread apart, and then the wedge is right there ready to be pulled down through the joint. Again, the picture, the drawing on the left here is a little bit more clear. You can see the wedge and see the joint, and then again, it's just pulling it. It's just going to pull. The wedge test is just pulling it through the joint, and it just measures the force to pull that wedge through the bond, through the adhesive bond. And again, this is something like again, thinking of a torque wrench, foot pounds, inch pounds, newton meters, and how much torque it takes to pull that through the joint. And again, typically measured with newton millimeters or joules.
Hey, Kelly.
So, yeah.
Kelly, we have a question here. Can you please elaborate more about peel strength and impact peel?
Okay, yeah, absolutely. So we'll go back here. So T-peel, when you think, and I try to use when you're doing a resistance spot weld, when you take two vice grips and you're just trying to peel that joint apart. You're just peeling it back. That's what's doing here. You're pulling, the test rig is pulling apart, and it's peeling, peeling that joint apart, where when you have impact wedge, that wedge is getting driven down through that joint very, very quickly. So it's going to come down and basically kind of like an axe and chop through the joint. So the peel test is just seeing how hard it is to actually just peel that joint apart, where the wedge peel is actually just driving that wedge through the joint. So it's just two different types of tests. And when you think about peel, think about like again, like adhesives with SPRs. With SPRs, self-piercing rivets, what I talked about on Tuesday, self-piercing rivets by themselves aren't that strong as far as when you compare them to structural blind rivets. The joint strength isn't that strong. But when you put them in a joint with adhesive, especially in a T-peel kind of scenario, the rivets are holding, pull the panel together while the adhesive is drying. But then in an accident, when that load is getting, that impact is sending force through that joint, the adhesive and the rivets are working together. And I'll get into that a little bit more when you look at the strength differences between a 1K adhesive from an OEM and a 2K adhesive that we use in a body shop. So I hope that answers your question with the differences. And again, these are just tests that are done. Okay, so what's the difference? So I wanted to kind of show you, to kind of put it in perspective for you, the 4601 1K adhesive, what Tesla used to build the Model S's and X's. So when you look at it, I talked about these earlier. You look at the peel strength and the tensile strength and the impact peel. So one of the things that was a very eye-opener for the adhesive engineers is the tensile strength. When they look at the 1K properties, it's much, much stronger than the 2K products. You look at the, it's almost, it's over twice as strong. But then when you start looking at other things, the peel strength is very similar. The lap shear strength is very similar. But if you look at that impact peel, the impact peel is much higher on the 2K adhesives. So again, Another thing too, when you look at these different adhesives and the 2Ks, yes, they're not as strong, but because the impact peel is higher, that does help manage the joint, the energy when the impact happens. And another thing to think about is when you're replacing a frame rail or a panel or whatever you're replacing on the car and you're using 2K adhesive, the rest of the vehicle still has that 1K adhesive. So you're only removing a certain part of the structure. Another thing to think about. But going back to when you look at the elongation, again, the elongation is much higher on the 2K and again, this is the 2098 from Lord Fuser. 2098, they're crash durable adhesives, a very popular adhesive by many different OEMs. But you can see the elongation is higher, but the modulus is lower. And again, those go hand in hand. But so again, just trying to give you guys some background. And here's the difference. I compared it to 2098 from Fuser as well as 3M 7333. Both very popular adhesives for different OEMs. But you can see there the differences on with the 7333. Again, the peel strength is relatively in the ballpark. The tensile strength is actually a little bit higher than the 2098, but still about a half as much as the 1K adhesive. What's interesting here is the elongation is lower, but the modulus isn't as high. But again, if you look at that impact peel test, again, very, very much higher than what the 1K product is. So again, these are, all this stuff goes into the test. And I looked at, when you look at, the structural adhesive versus the panel bond adhesive, I reached out to Doug Craig at Fuser, and unfortunately I wasn't able to get they didn't have the other peel strength and tensile strength test done for the 2AB, but just look at, again, look at the impact peel difference. So when you look at the lap shear strength, again, when I talked about earlier is the 1K, or sorry, excuse me, the 2K adhesive, the panel bond versus the structural adhesive, they both have a very good tensile strength. The adhesive sticks very well. So you can see the lap shear strength is very, very similar to each other. But what's really scary here is the difference between impact peel. So again, when we talk about that sudden crash scenario, like that BMW that got rear-ended, the 2098 2K adhesive is rated at 30 Newton meters, but the 208B, the panel bond adhesive, is only rated at 8.5 Newton meters. So again, the crash durable 2K 2098 adhesive is over 3 times as strong when you compare it, almost 4 times as strong when you compare it across. So that's, those are the big differences when you look at, doesn't matter, it doesn't so much matter when you glue it together, right? It sticks, the adhesive sticks, everything's good. It's when the car gets put into a crash scenario where the joints can fail. And again, when you start looking at the compounding issue, okay, all right, the technician didn't use the right rivets. They used the wrong structural blind rivets with the wrong grip range. And then, it doesn't matter what adhesive I use. I'll just use the panel bond because that's what I have. I don't have any 2098 on hand. I'll just grab the 208B. So, this is where you can have a big recipe for disaster when you use the incorrect rivets that are called out in the OEM repair procedure, and then you use the incorrect adhesives. Again, this is, adhesives are stronger than welds. And one of the reasons they are stronger than welds is because they're covering a much larger surface area. And, when you think about a spot weld or even a MIG weld, that spot weld is only covering that small button diameter that it's welding, but all the way around between the two welds, if there's no adhesive, there's no strength there, right? It's just the strength is between the welds. Same thing with the MIG weld. When you butt weld a joint, the strength is only at that particular point. And that's one of the reasons why you're going to see more and more adhesive and riveting applications on repairs, is because in these sudden crash modes, it's actually spreading, the adhesive can spread the energy out across the joint. And again, so these are the things that really impact the vehicles when you start looking at high strength steels. I think everybody has lived the pain now. These high strength steels, the repairability isn't as high, and you're seeing where it's a remove and replace part because the metal's so thin, and they're not, it's just really a remove and replace option at this point. Is there any other questions, Jason, before I get into talking about a vehicle that I repaired in the past?
Can you still slide with the 8115 again, please, on it?
So I unfortunately wasn't able to get the information from 3M on that. So I will follow back up if I can get that with you on that one.
Can you just go back to the slide? Can you just go back to the slide again, though?
Sure.
There you go. All right, cool. Thank you.
No problem. Yeah, no problem. So, okay. So this is, again, I like to use personal experiences when I do these different presentations because, it really try to drive home the point that, this stuff kind of happens every day. It may be kind of hard to recognize what you're looking at, but this is actually a Tesla Model S with the entire rear end of the car cut off. I went to Japan in 2014. At the time, we were tracking all vehicles globally, and this particular car had been in the body shop for many months, and we kept contacting the shop and really wasn't getting anywhere, and really not understanding what the problem was. So I went to Japan to see what was going on, and also to help the shop if they were struggling. And when I got to the shop, this is what I saw. Again, they had cut the wheel houses out of it, the rear body panel, the quarter panel's obviously off. It was definitely an eye opener for me. This is on the driver's side. They cut the outer sheet metal off of the B pillar. I went through and I had a translator there, and I kept asking the translator, well, where's the metal at that they removed? So we went out outside the shop, and they had a pile here. And I was digging through all the parts, and I really didn't see much damage to the parts. So I was really confused why they did what they did. And I never did get an explanation, and I really, still confused to this day. But on this particular part, on the B pillar, what you see there in E-coat is actually steel. The Model S has steel in the B pillar, but the outer skin is aluminum. Luckily, I had developed a procedure to replace the outer sheet metal on the B pillar. But what we found in the field is every time that sheet metal was damaged on the outside, the B pillar was damaged on the inside. Typically where the hinge bolts are at. And you can see here where the hinge bolts, there's no damage. There's no, nothing's disconfigured or anything like that. So again, they cut all this stuff apart and was able to, one of the things I did as well before I left and flew to Japan is I looked up the parts orders, and I unfortunately only saw one parts order. So I knew they had ordered a wheelhouse and a quarter. So I knew it was a larger job, but wasn't expecting that. What happened is I missed the other 5 parts orders that they had put in on this VIN. So they had ordered all these other parts, but this particular repair, encompassed every single adhesive and rivet, research and development test that we involved. When you look at the amount of parts that were replaced, the amount of rivets used, the amount of adhesive used, that's all the testing that I did and that I didn't do, that I basically project managed, went into fixing this particular vehicle. You can see, I was at this shop for 3.5 days. I didn't get the car completely finished, but we got everything on the inner structure installed, and I got the quarter panels dry fitted, and then the shop finished when I left. But in this particular picture, we have all the wheelhouses installed. You can see, the wheelhouse assembly up at the roof was self-pierced rivet at the factory when Tesla builds the cars. But in that particular repair, blind rivets are used. And that joint there is very, very, obviously a very important joint, because you need a lot of strength there, because that's what's holding the roof to the wheelhouse assembly. So, when you look at the different tests that we did, the adhesives, again, the 2K adhesives that we tested weren't as strong as the 1K adhesive that they use in the factory. But when you pair that with a structural blind rivet that is much stronger than the self-piercing rivet joint, that's how we were able to overcome, the weaknesses, or not the weaknesses, just the differences in the different adhesives. So, that particular joint there is a perfect example how, yes, the adhesive isn't as strong, but we can use a stronger mechanical fastener, a stronger rivet to overcome that difference. So again, this car was able to be put back together. I stayed in touch with the shop and made sure and got pictures, because I definitely wanted to see this one completed. Here's a picture of the car basically ready for paint. You can see they got it primed and got seam sealer on all the joints. And then here is the picture of the completed car. So again, this a very, very large repair, but when you follow the repair procedures and follow what the OEM calls for, this repair was done safely and no concern for anything in the future for the length of the vehicle's life. So that kind of wraps my presentation up here. I'll gladly take any questions. Realize I went through a lot of things, but just really wanted to drive home, the need for everyone to follow the OEM repair procedures and use the correct adhesives, use the correct rivets for the repairs that are being done out there.
Awesome. Some great content as always, Kelly. Appreciate that very much. Just one comment here from Ryan says, can we specify that we can't just add adhesive anywhere just because it's stronger? Yeah, good point there, Ryan. So let's make sure we're following those vehicle maker procedures with everything and make sure we're using the proper adhesive. We had a presentation the other day, kind of talking about some of the differences between, adhesive, the bonding adhesive versus kind of the crash toughen adhesive. So it's imperative that we're putting the proper adhesive in there as well when it's called for.
Yeah, absolutely. Again, I was just actually looking at some information from Chrysler, from FCA, Fiat Chrysler, and in their repair procedure, it calls out, because they use some structural adhesive, and then they also use like a sealer. And it says right in the repair procedure that when in doubt, if you're not sure if it's structural adhesive or if it's a sealer, just use the structural adhesive. So, again, it's very specific to the OEM. You never know, how they look at it. And, just look at Chrysler, for instance. They don't call for the use of weld-through primer. So these are these are the challenges. And I said it on Tuesday. It used to be easy to fix a car. It was easy, right? You could apply the same, mythology to almost all the cars because they were all made out of mild steel. Nothing's easy anymore in this industry. So.
Anybody else have any questions? All right. Well, then, Kelly, thank you once again for joining us this morning. We really appreciate your time and your expertise. It's always a pleasure to listen to you, and I always pick up several nuggets every time. So I really appreciate all your expert insight
Yeah,
on
no
everything.
problem.
So, and with
Yeah, I
that,
appreciate you guys.
Krista, what do we have up? What do we got next, Kristen?
Wow, have we got a day packed. So next up at noon Central Time, Mitchell will be here to talk about diagnostics. And we'll cover kind of from a perspective of estimating what all is in diagnostics, what all does it take, what all labor is there, and is it really just plugging in a machine and pushing a button, or is there a lot of other work that the shop and the technicians have to do? So that should be a good one for discussions and questions, and lots of talk on that one.
Awesome. Cool. So that's at noon, correct? 12 o'clock
Yep.
Central Time. Awesome.
Yep,
So
that's at
in an hour.
noon.
So
Yep. We'll see everybody then.
well, go grab a bite, Kristen,
Awesome.
so you can eat today, and we'll see everybody in an hour.
Awesome. Bye, guys.
Thanks again, Kelly.
All right, thanks everyone.
Bye bye.